In this lesson we're going to continue to look at the heat loss problem. This time we're going to look at how the shape of an object can affect the rate at which it loses heat. So to illustrate this, we've got the cube from the previous lesson, and we remember that its side is 8 centimeters long. Okay, so its volume will be 8 by 8 by 8, which is 512 cubic centimeters. And we can calculate its surface area, and its surface area will be 8 by 8, which is 64 multiplied by 6, which is 384 centimeters squared. Okay, so when an object loses heat, the only place where it can lose heat is through its surface. Right? There's nowhere else. There's no other place where it can lose its heat. So if our object here is at 60 degrees Celsius and the surroundings is at a lower temperature of 20 degrees Celsius, then it will gradually lose heat, either by conduction, by radiation, by convection, if it's a liquid, by evaporation, but heat will be lost from the higher temperature to the lower temperature, and we can assume that the rate at which that heat is lost depends upon its surface area. That's to say, the greater the area, the surface area, the faster it will lose heat. That's absolutely reasonable. So the heat loss depends upon the surface. So let's think about what happens if we change the shape of this object. So what we're going to do is we're going to introduce another object with exactly the same volume, with exactly the same temperature, and made from exactly the same material, but it's going to have a different shape. Okay, so this new object is at 60 degrees Celsius, it's made from the same material, but it's clearly got a different shape. This time its length is 32 centimeters, its height is 2 centimeters, its width is 8 centimeters, and if you do your calculations you'll find that its volume is exactly the same as the volume of this cube. What we need to do is check the surface area. So its volume is again 512 cubic centimeters, but its surface area this time, if you do your calculations, and I've already done this for you, but you can double check if you want, its surface area will be 668 centimeters squared. So by flattening this cube, what we've done is we've kept the volume the same, but we've increased its surface area. So which of these objects will lose heat faster? Well, the flatter shape will lose heat faster. As I say, its temperature will fall at a greater rate because it has a greater surface area. Likewise, if I flatten the shape even more, so I've kept the width the same, that's still 8 centimeters, but the height now is 1 centimeter and the length is 64 centimeters. And if we do our sums again, we'll find that the volume of this shape is exactly the same. 8 times 64 is 512. There's a lot of maths in this lesson. 512 cubic centimeters, but its surface area is bigger. The surface area is 1168 centimeters squared. So its surface area has got a whole lot bigger. So this shape will lose heat a lot faster than this one, which will lose heat a lot faster than this one, because it has the bigger surface area. So you might ask, what is the ideal shape? Well, the ideal shape for conserving heat is a sphere. So what we can do is we can take a sphere of 512 cubic centimeter cubed and work out its radius. Let's say that this sphere has a volume of 512 cubic centimeters, exactly the same as the cube and cuboids that we've just looked at, and well, we can work out what its radius should be, and in fact if you do that you remember that the volume for a cube is 4/3 pi r cubed, and if we make that equal to 512, you will find out that the radius is approximately 4.96 centimeters. And if you then calculate the surface area for this sphere, well, we remember that the surface area for a sphere is 4 pi r squared, we plug that r in, we'll find that the area is approximately 309 centimetre squared. So that's the smallest surface area that we can get for a volume of 512 cubic centimetres. This is the ideal shape that minimises the heat loss from an object. Now, curiously, it turns out that nature has already discovered this rule. For example, this little fellow knows very well what shape he's got to adopt in order to reduce his heat loss. Who is that? Well, it's this one. Okay, so it's a little dormouse having a sleep. It's hibernating, I'm not sure. But you can see clearly that little animals know that in order to reduce the amount of heat loss, they have to minimize their surface area. And so the best way to do that is to roll yourself up into a ball. Okay, and in fact, you do the same thing probably when you're in bed at night. If it's a very cold winter's night, then you would tend to huddle yourself up. You squeeze yourself up into a ball because you lose less heat. If it's a very hot summer's night, you're kind of spread out, right? And you do this because you increase your surface area and therefore you increase the rate at which you lose heat, which is what you want to do if it's a hot summer night.